Welcome to this brief tutorial on how to program servo motors using PIC microcontrollers. These motors are pulse width modulated and require a pulse width at 50 Hz to drive the motors through its degrees of rotation. Let's take a quick look at this sketch. You will notice at 0.8 milliseconds the motor is at the 0 degrees position. By gradually increasing the pulse width to a maximum of 2.2 milliseconds, the motor rotates from 0 degrees to 180 degrees. You can have either continuous rotation servo motors or servo motors that rotate from 0 to 180 degrees, like the type used in this project. If you are new to programming microcontrollers, I would recommend using one of these prototype boards which come with a configured power supply and an ICD connector for your programmer. The board used in this demonstration has a PIC 18F4550 microchip with a CPP output at pin 17 to control the motors. Although you can use any PIC-C compiler, I'm going to be using the CCS C compiler to program the microchip. Let's take a look at some sample code on pulse width modulation. If you have some programming experience, you should be able to identify with most of the code. Perhaps the only bit of code that requires explanation is a counter timer configuration, which is used to set the frequency and the pulse width of the modulated signal. 3 parameters are required to be set in the timer function: the prescale, the period, and the postscale. Take a look at how the configuration parameters are used in the equation to determine the frequency and the pulse width of the modulated signal. You can also write your own interrupt routines to control the servo motor using a separate counter timer. We can now use this information to build fun projects like a push-button controlled servo motor. If you have any questions, you can email me at my email address at the end of the presentation.